Good morning, everyone present here. Welcome to today's KWK talk. I request our director, Dr. B.R. Guruprasad, to welcome the gathering.
Thanks, Sharanya. Respected speaker, Professor Rukmini, Anupam, and the audience, as well as the staff of Jain Planetarium, and those of you who are joining the lecture through web. Good morning to all of you. I welcome you all to this presentation today. A very interesting topic. You know, Kaapi with Kuriosity, this program is jointly organized here by ICTS and Jain Planetarium. And all of you know that Jain Planetarium is one of the prominent centers for science popularization and non-formal science education here in Bengaluru. And we are organizing many science popularization programs, including the planetarium shows, sky shows, and many other programs for students and the general public at large. And you know, to put it in the proper perspective, 2 days back, we had a program for specially challenged children. Okay, they congregated here and they built some models and all those things. Really, I really thank Sri Hari Parameshwaran for this. Excuse me. These are some of the problems associated with modern technology, in fact. So, anyway, 2 days back, we had a wonderful program where specially challenged children, they came and they built some models. It was a wonderful sight to see them and the sense of satisfaction. And that was one part of it. And it is really amazing. Yesterday, we had a program, yesterday night, Winter Skies at the Planetarium. In fact, what are all the constellations, the planets, the heavenly bodies which are visible at this time in winter. That program was very ably handled by Dr. Anand, who is there. Amazingly, he has come back, even after being awake for a whole of the night. He has gone home and come back for this program. Anyway, thank you very much for this wonderful thing. Thank you, Anand. And now, continuing with this, 24th to 26th, we have a program on science in action. Okay, that is again, you know, building of models by students. In fact, it is not only curriculum-based thing, but practical aspects. That is the thing. So, against this background, whatever programs we have, today's lecture, you know, as part of Kaapi with Kuriosity for this month, high-fidelity sound reproduction. And what is more important is the second part, practical aspects for the DIYer. In our country, this is not much. Only in the United States, DIY, for a long time, I didn't know what it was, do it yourself kind of thing. Okay? So, that is the way, you know, many people learn carpentry, these electrical stuff and all those things. Here, we don't have time at all for such things, I think. Slowly, things are coming, and it is good. And I am sure that Shri Reji Philip from the Raman Research Institute, I am sure that he will handle this subject very well. First, let me thank on behalf of Jain Planetarium for his kind gesture of agreeing and coming here to deliver the talk. And I thank ICTS, Professor Rukmini, Anupam and all others for being responsible for this. And with this, I once again welcome you all. And now I call upon Sharanya to announce the next event. Please.
Thank you, sir. I ask Professor Rukmini to introduce the speaker.
Thank you. So welcome everyone again. It's my great pleasure to introduce the speaker. Professor Reji Philip is a professor of light matter physics at the Raman Research Institute. He has nurtured a deep passion for music and audio systems, a hobby he has ardently pursued for over 3 decades. His enthusiasm led him to experiment with a wide range of audio amplifier designs and loudspeaker arrangements in his home setup, all in pursuit of achieving the pinnacle of high fidelity audio. So today he is going to share with us some of his experiments. Welcome to the talk again. He is going to talk about high fidelity sound reproduction, practical aspects for the DIYR. Okay, Professor Philip.
Yeah, thank you.
Before we start, we would like to hand over a memento to Professor Philip.
Thank you so much. Thank you. So thanks a lot, Rukmini, for those very kind words of introduction. And I'm really honored by this invitation to speak here on the auspices of ICTS on high fidelity sound reproduction and particularly the practical aspects of it. And I also thank Sam Supurna for requesting me initially for this, and also for Anupam for all the other arrangements, for picking me up from home today morning and helping me with bringing all this stuff here. So thanks a lot to all of you. So in fact, I had given a talk in similar lines earlier, but that was more on the, I think the theory content was a little more in that, but for a general audience, what matters more is probably the practical aspects of it. So like today I will be telling you how to really make one amplifier system all by yourself. If you have, I mean, we have all the resources basically in the country now. We can buy the boards, everything can be, transformers can be made in SP Road to order. So all this is possible. And so that's for first, maybe half of it, I will also take you through the history of high fidelity sound. Is it not working? Has it has battery in this, or maybe? Oh, sorry. Yeah. Yeah, it's moving. Okay, good. So the contents of this talk will be, first we will look at recording and playback, the historical perspectives. Then the analog era, you know, it's a forgone era now. We are in the digital era now. So digital, then some comparison of both. Then we will come to audio system components and topologies, you know, DACs, preamplifiers, amplifiers, speaker systems, home theater. Then finally the comeback of disc records and turntables, which is happening right now. And finally, there will be a demo of a home-built 2.1 audio system here. So with that we will end. So looking at the audible frequency range, the ear is a remarkable organ of the human body because its dynamic range is really extreme. So this is a kind of, you know, the threshold of hearing. If it is I0, then the threshold of pain for the ears is 10 to the power 13 times I0. So that means the dynamic range of this organ is really large. We cannot really make anything electronic with this kind of huge dynamic range. Then we have, so what we normally hear is from 20 hertz to 20 kilohertz is what this is for. This includes little babies to old people, because as we grow old, our ability to hear the high frequencies get diminished because the tympanum becomes thicker and thicker. But babies, infants, they can hear up to 20 kilohertz. So my own hearing is limited by 13.5 kilohertz actually. This has been, you can test it very easily. So now these are the regions where all these different musical instruments lie. Human voice is actually, it has only a short, if you have good frequency response from 300 to 3000 hertz. That is good enough for all male and female human voice. So this is why in telephone conversation, you don't really need much bandwidth because you just talk to each other. So this kind of a bandwidth is more than sufficient for talking to each other. But then we have a lot of instruments. So if we look at the low bass instruments, musical instruments, they are way down close to 20 hertz, and then there are all this kind of stuff, and the cymbals, they all make treble sound at the high frequencies. So a music system should be able to reproduce all these notes. So therefore, it should truly have a frequency response starting from 20 hertz up to 20 kilohertz at least. Usually all the high fidelity systems, they will have frequency response, flat response up to 100 kilohertz actually. Looking at the historical perspectives, so who actually made the very first recording of human voice? This is what is recorded in history. The instrument called phonautograph in the 1850s was developed by a Frenchman. The sole purpose, it was not, the idea here was not to reproduce the sound, but the idea was to visually record the vibrations of the human voice, so that they could be studied by those people who are involved with human speech. So people were studying human speech. That's why this was recorded. And this is how the instrument looked, something like this. I mean, I'm sure those who have read Asterix comics will be reminded of some pictures there by this huge thing here. Anyway, a thin brush which was attached to a diaphragm would make tiny tracks on blackened glass. So this is one of those recordings which has been fortunately preserved. And at that time, nobody really thought of reproducing the recorded sound from phonautographs. However, by the 1870s and all, Edison, Thomas Alva Edison, who was a great inventor, he recorded sound on tin foil. So this was the real modern, if I can call this modern, or the very first sound recording medium in that sense, and played them back. And he called his instrument the talking machine. The recording was what you call vertical recording there. And later, after 10 years, he started using wax cylinders for recording and named this device the phonograph. So this is considered to be the first device which is durable. Like even we have these things even now. I mean, there is a museum in Kerala where the owner of this museum has a few Edison phonographs now. He also has the wax cylinders. It actually plays. I mean, there are many, you can look into the internet and you can see several sources where you can see the wax cylinder playing on the Edison phonograph. So some of these have been preserved very well. So we can also see that in those days, all these instruments were looking very good. They were not like boxes, like, I mean, now we have rectangular boxes which don't really look any, there is not much of aesthetic sense there compared to what it was in those days. In fact, this is all very clever ways of amplifying sound. For example, this is a horn. What you have here is a horn, but the manufacturer has made it in such a way as to look like an angel or whatever, but this is a basic idea. Nowadays we don't really worry about those things anymore. So before electricity, from 1888 up to 1925, the recording was acoustic because there was no electricity, even though you could record these things. So to reproduce, you have to really use these kind of horns, these megaphones for amplifying the sound. So this is the way it was. Look at the recording here. So this is how in recording studios, if at all we can call them studios, this is the way they did it. There's a huge horn here. So it is the, how clever the orchestra conductor is, because he has to keep people at different distances. There's nothing like separate microphone for each instrument or each player. There is just one big horn, and so you have to keep them at proper distances so that finally the recording is something that is good to hear. Actually, some of these acoustic recordings are very good to hear. I heard somewhere, but I don't have a sample now. And it's also imperative that in those days where there was no electrical amplification, any singer should have a very loud throat. This is also important. You know, those dramas which happen in huge auditoriums and big auditoriums in those days, there are songs. The singer has to sing in such a loud voice so that, you know, somebody who is sitting in the back also should hear it. So nowadays, singers don't even have to sing in pitch, because even pitch correction is possible in the studios. That's how all the quality has come down because of this. People, my friends who work in sound recording, they tell me, even famous singers, they struggle. The sound engineer, they come, sing and go. The sound engineers struggle afterwards to, you know, bring everything in pitch and roll, because they have also become careless. They know, in olden days in sound recording studios, it is just one take. For getting that final single take correctly, you may have to do 20-25 takes. People like Ilayaraja are known for this. I mean, the singers will sweat. You do 20 times, and olden days, okay? So when everything had to be taken in one shot. If there is one mistake, you have to do the whole thing again. No multi-channel recording, nothing. Nowadays, singers sit in the US, they sing, send the FLAC file to India. The orchestra sings in 5 different places, everything put together, beautiful music comes out in the end. So the effort is mostly that of the studio engineer more than anybody else nowadays. Anyway, it was not possible in the olden days. And now comes 2 other things. These are called graphophone and gramophone. So gramophone is what finally became popular. So many of us must have seen gramophones in our homes in the younger days. We also had one. And some other people also got patents for the wax cylinders for recording and playback, and they called it graphophone. But then somebody by the name Emil Berniller from Washington DC, he designed and took patent for the gramophone in 1887. So this used a disc instead of the cylinder. So many of us haven't really seen a cylinder, but we have seen the disc. So this is where it all started, and the original record disc was made of zinc, but it would not stay much long. So therefore, it was changed to shellac. You know, shellac also breaks, but this was the material which zinc records. I don't think anybody has seen it. No, it did not stay for long. But shellac records are there. Still, they are there. So the advertisements in those days for selling the phonograph, and you know, so this was what it was, and very similar to the techniques we use nowadays for advertising this stuff. Now coming to the record player or the turntable from the gramophone, the first gramophones were hand wound. So there is a gear and all that. So there were 3 kinds of records. The standard speed at that time was 78 RPM on shellac. So this would say just 4 minutes of playing on one side. So 4 minutes is like one song. So you cannot really have more than one song on one side of the disc. So one disc usually has 2 songs. I mean, one on each side of it. That's the way it was. And then electric recording comes in 1925, and then the record player came. So until then, you had to hand wind it. I have done that in my father's gramophone. Hand wind and then, you know, let it play. It's like, you know, the watches. We had the wrist watches. You have to wind it. I mean, the kids will not even know these things. I mean, the old watches, we had to wind it every day to make it run. So they were, and some were called automatic watches, like, you know, I mean, just by the motion of the hand, they get wound. So you don't really have to give the key. So all those techniques in gramophone also. However, by 1925, you have electric recording, and now the electric motors came. So no need for hand winding anymore. And the speeds also got changed. Now 45 RPM, 33 and 1/3. So these 2 were the standards. And these were called LP, long play, because you can accommodate more songs on either side of it. So these 33 and 1/3 LPs, they can actually carry something like 12 songs, taking both sides of it. And less noise, about 22 minutes play per side. And I still remember this movie Shankarabharanam, which was on classical, based on a classical Carnatic musician. So when the records came, the initial records were not really done properly. So the needle would just go up like this while playing. So then they reissued. They never expected the movie to be a hit like that. So done by some startup company or something, they did not do a good job because they didn't have the experience. So eventually after 3 months, the movie became such a huge hit all over India. And so they changed this company and they reissued their records. This was a time of vinyl records. Cassettes were just coming in. So that's the story of this thing. It had completely disappeared from the market, but now these things are coming back. I will speak about that in the end. So the record labels, there were many: Universal, Sony, His Master's Voice. This was very popular. It's about, the story is that of a dog which heard the sound of his master from a disc, and the guy would not leave the instrument. He would just sit there because he got very confused. So that's how this His Master's Voice, that emblem came. Then this is actually the name for, this is Grammy Awards actually originates from the name gramophone basically. So there are different kinds of, so how does the record play? How do we get signal out of it? This is analog recording, means continuous recording in a group. So you have styli, we have two types of styli. One is piezoelectric. So it has high output, like it can give voltages like 1 volt, 1.5 volt and all that, which is quite high for any kind of power amplifier. But the problem is these are not high fidelity. And also you have to, it will destroy the record, it will also destroy itself. So after several plays you have to change your piezoelectric stylus. So people prefer actually the magnetic stylus, where there is a magnetic coil. So it uses magnetic pickup, because the stylus moves in the track, and then this coil, an EMF will be induced in the coil, so that is taken out. Only problem is these kind of phono cartridges, the output is very, very small. It's like 2 millivolt, 3 millivolt. So noise is a problem, but these issues have been solved. So there are very good magnetic cartridges now. You get it, I think, for starting price maybe 2000 rupees or something for those who actually use the record players, and it can go up a lot. So then we have reel to reel or spool tape. So maybe some of you have seen this. These are big tapes, so this size. So these were the original spools, and in studios they used to do the master in spools. Even now analog studios, they have almost disappeared. Nobody does in analog anymore. So the analog studios used to do this in spool. Once I had the good fortune to hear a studio master on spool. So it was actually so good. Then only you realize that the copies that we get in small cassettes, and they're all degraded actually, intentionally. I mean, it's not, because a studio master is much, much better. Then this is what we normally used to have in those days, cassettes. 2-3 different types of cassettes were there, and the technology of the cassette was so good. It was advanced to such a level that even now the good cassette player and a well recorded cassette is a notch better than a CD. That is the situation, but cassettes anyway got out of favor, and in fact these machines now they have become vintage, and they fetch a very good price if somebody is trying to sell vintage equipment like that. There are websites where you can get a lot of very good price for this. There are people looking for these things, and some people have made it a business, because many of these may stop working after, because they're old, like 20 years, 25 years. There will be some little problem, like maybe a capacitor is shorted, but it doesn't work. And the modern people really don't know how to repair these, because in modern times there is practically no repair. It is use and throw. So they go to junk, and in junk shops one can get, if it goes to junk, you can get it for 1000 rupees, 1500 rupees and all that. And there are some people who regularly go to junk shops and collect these things. They take it home, they repair it, they sell it at a very good profit. So such a market also exists. Now this was the tape head. So how does because it is magnetic tape, this used to be the sensor. So this is called the tape head, and you know, I still remember buying these heads, high quality heads which were called glass heads and all that, for 200 rupees and all in my student days. So we would remove the stock head that comes with the mechanisms, the cassette mechanisms, and put these glass heads and high quality heads. The sound quality is much better with all those things. So there used to be preamplifiers also. This IC called LA3161 was very popular, this long IC like that, thin and long. So we used to make these circuits and run our own systems in those days. I am talking about 30 years before. Now this is just a photo I got from one of the WhatsApp groups of in which I am also a member. So you know, these kind of systems people have preserved even now, some of these 20 years old systems, and somebody has integrated a USB player and also the Alexa to that. So you just give the input through the aux input on the back side and it plays very well. So just a photo of okay, so that was the digital side of it. And so now comes the digital era, and what happened there in the digital is now the analog recording disappeared. So every recording became digital. So basically you have analog to digital conversion to begin with. So sampling the analog signal at a sufficient rate, this is important, the sampling frequency basically, and measuring each sample with good resolution. So bit depth. So these two things are important. Now this opens up a lot of possibilities for recording, because you can do a lot of manipulation on the original. When the data is digital, it is possible to do many things on that which you cannot do on the analog data. So that is a huge advantage of digital recording, and of course this is not going to go away, because digital recording is actually very good. The quality is actually very good. It can equal the analog recording, at least in the studio. So we will see how we can get really very good digital files. Now this is what is done. So the usual standard for audio is CD audio, and in CD the sampling rate is like 44.1 kilohertz. This is following the Nyquist theorem, which says that whatever is the highest frequency in your signal, the sampling frequency has to be at least twice that. So for us it is 20 kilohertz. This is the possible highest frequency in any audio signal. So 40 is the minimum sampling frequency you have to use. So 44.1 kilohertz is the standard frequency for CD recording. And for DVD audio, which is this is actually the Studio Master. So here it is much higher. It is 192 kilohertz. It used to be, but now people have started reducing this for practical reasons, because if you sample your audio signal at 192 kilohertz, the file size will be so huge. So nowadays, you know, I mean, you don't really transfer these things physically, unlike, you know, everything is going over the internet. So it is necessary to keep the file size smaller. So people have did their experiments and found that 192 is a little too high. It's not really, probably not required. So therefore coming down to half of that, 96 and all that. So anyway, the other quantity is bit depth. So you have, let's say you have sampled. So one sample you have got. Now what is the resolution? In what resolution do you measure the voltage of this sample? So that is what is meant by bit depth. So CD has a depth of, it's a 16-bit depth, which means 2 to the power 16. These many possible output levels are there. So that's the kind of resolution we have in the CD. And for DVD audio, this is 24-bit, which is much more. So as I said, Studio Masters are typically 24-bit 96 kilohertz or 192 kilohertz. Can we hear the difference is basically the question. I can do in 192, but am I going to hear any difference compared to 96? Many people just don't hear any difference at all, but your file size will be at least half of the other one. So bit rate, we are familiar with bit rate, so many kbps and all that. So what that means is sample rate, that is sampling frequency, multiply that with the bit depth and then multiply that with the number of channels. When you do that, you get the bit rate. So take audio CD, so the sample rate is 44.1 kilohertz, multiply with bit depth 16 bits, and for stereo this is 2 channel, so multiply by 2, so that gives you 1411 kilobits per second. So this is the standard audio CD audio bit rate. Now we should compare this with our MP3 and all that. I'll come to that. Now uncompressed, there are different kinds. So if you have a CD, you have a CD player, let's say you are playing it in your system, what you are playing is uncompressed audio CD signal. So this will certainly sound very good in a good system. However, when you want to transfer these things over email or then you have to reduce the file size. Because a CD, one song can be as large as 65 MB, 70 MB, so that if it's a FLAC file, it's lossless file. So you don't have that kind of space. So people have compromised. So this is an uncompressed file which is linear pulse code modulation, LPCM. You actually get this from high definition TV, for example. LPCM comes. You can see that on your AVR, LPCM, if you choose it. Then in audio CD also. So this is usually saved as a WAV file in Windows. It's a WAV file. Now you can compress it, actually bring it to a smaller size, but without losing the quality. This is called lossless compression. So that is what FLAC is, free lossless audio codec, FLAC. So FLAC has become sort of the standard for audio these days. It is good quality and it is not as, it doesn't take as much space as the CD. So therefore this is a good balance, good yeah. Now we have lossy compressed after this. So that is MP3, the typical MP3 file, MP3, AAC, etc. These are lossy files in the sense that I just told you for the CD the bit rate is 1400 and above, but for the MP3 the bit rate is as reduced as 320 kbps, 256 kbps, 128 kbps, etc. So my own experience is that up to 256 kbps it's okay, but anything less than that you are seriously losing lot of data from the original master. So it is not really worth hearing anything, but nobody cares. I am going to come to that after this. So how do you know? Now it is very easy to sell you something with an extension. There are people who sell high resolution audio in the internet. So they tell you this is a FLAC file because you see an extension FLAC, or they say this is a WAV file because you see .wav. But does it really mean this is? Not necessarily. See, somebody can take an MP3 file and convert it to FLAC or to WAV because there are such converters. So it will convert and give it to you in that format, but doesn't mean originally there is no data. Okay, that's what you get in this guise. So what you should do, you have to do a spectrogram analysis, spectral analysis of the file. There are websites where you can just put it, there are apps actually which you can free download. Use the app and look at the spectrums. Now here you can see for this lossless sound the spectrum goes up to 20 kilohertz, and for here for the MP3 it doesn't go all that way up, it goes only up to 16,000 hertz. So from this just put your file for analysis, you will immediately know whether this is truly a high resolution thing or not. Okay, then as I told you, a lot of things are possible with digital audio processing, both in the studio and also on the stage. So for any stage program, I am sure you have seen the people who control the whole thing with a mixer, a huge mixer will be there depending on the size of the program. If there are 20 20 instruments and 5 singers on the stage, you need to have at least 25 channels on your mixer. So there are mixers with 64 channels and all that. Each can be adjusted. The tone of each can be adjusted. For female singing, for example, you have to pitch it accordingly. For male singing, you have to do it accordingly. For instruments, you have to do this. So the person who does, the sound engineer, has to be really experienced. Otherwise, he can mess up the entire. I have seen that happening. You know, somebody on the controls who really has no clue what all this is. He keeps turning this and that and messes up the entire program. So the sound engineer has to be really experienced and should have some know-how of what is happening. Many things possible. In guitar, for example, distortion is introduced intentionally. There are distortion amplifiers for this, because guitar sounds better in some instances like this. Then volume pedals, there are pedals. The guitar player actually has pedals and all, so he uses all that. Compressors are there, graphic equalizers, modulation is possible. We can have a choral singing is possible just by electronic means. Many things, pitch effects, pitch can be shifted. Time effects are very important. So any singer for that matter, the first file is flat. So this is what you call the studio, the first recording will be very flat. The engineer hears this on studio monitors. So studio monitors are speakers with a very flat response. So no equalization, nothing. I have actually heard one of the these files of Yeshudas. The sound is very good singing, but this is not the sound that you hear. The tonal quality of the sound is very different in the original one. Now the engineer introduces echo, reverberation, all those things into that, tonal adjustments, what is required is that the musician should be a good musician. If that quality is satisfied, then they can change your sound like anything in digital. Chennai Vaidyanatha Bhagavathar, okay, great musician, right? But he doesn't sing like Yeshudas. But Chennai's voice can be brought to very similar to that of Yeshudas by studio processing. It is possible. Anyway, of course there will be differences, but I'm just saying all that is now possible. And another thing which is very common nowadays is dynamic range compression, or DRC. So why they do this is because of the change in the habit of people in hearing music. So nowadays, in olden days, people used to hear in bigger systems, like what I'll be demoing today. So these were the home systems. So these were the days prior to the mobile phone. Okay, so the mobile phone was not a device which anybody used for playing music. Even the very first generation of mobile phones, they were just phones. You know those button phones, right? They're just phones. They don't really do anything else. You can talk to each other, you can text also. Beyond that, you cannot do anything. But when the smartphones came, they can do so many things. They are cameras, they are music players, everything. Now the issue is the following. You just connect to your mobile phone using earphones, right? So you don't use big speakers. So whatever music is there, whatever is recorded, all that should come out within a very small dynamic range, because the dynamic range of your earphones is so small. It cannot go from a low volume to a high volume like this. Now, how do you really reproduce a symphony orchestra through your earphones? Impossible. Because in an orchestra like that, the dynamic range you have, like for example, there are some passages where there is total silence. Then after that, an instrument, a flute or something slowly comes up, okay. The next moment, there is a big explosion, okay, very huge, a huge sound. So this is the way it goes. Now you cannot reproduce the whole thing in your earphones, but that is the requirement of the consumer. The customer wants it. So when the customer wants something like that, companies will adapt to it. So they have adapted. The technique they do is to compress the whole thing. The dynamic range is compressed. So what is done there, the lower parts, the lower volume is raised and the higher volume is brought down. So therefore, you have a compression there. That is what we get in most recordings these days, the compressed part. So that is another thing that causes distortion in the system. And looking at media data storage, the original CD-ROM, 71 of those discs are equivalent to 1 DVD, and 10 DVDs are equivalent to 1 Blu-ray disc. Now nobody uses disc, by the way. I mean, only people like us have some CDs with us. Now everything is completely digital. Everything is in the air or in the cloud and all that. So a Blu-ray disc can actually store 50 GB of data. So this can accommodate a 4K movie with sound encoding in Dolby Atmos. So the Blu-ray is capable of that. Okay, so now we come to the more hands-on part of this talk, systems and circuits. So what are the components of a good audio system? Say a good home audio system. So we will have some kind of a source, a sound source here. It can be a turntable. A turntable needs its own preamp, because as I told you earlier, this is like 2 millivolt, 3 millivolt. So you cannot really take all that 2 millivolt to any long distance for that matter, because there will be noise, EMI will be there, so it will mix with. So therefore, all turntables have a preamp in that box itself. That signal comes out from that. CD player doesn't need that kind of, it also has, by the way, whatever. So you have some input which produces something like 100 millivolts or something, and then this goes to a preamplifier. So it is in the preamplifier that you have all these controls, like, you know, volume, bass, treble, balance. And if you have other inputs, like, you know, nowadays karaoke singing is very popular. So, you know, you will play something through your amplifier. At the same time, you want to sing also using microphones. So there will be microphone inputs for that. So all these things are usually done in the preamplifier stage. From the preamplifier, you go to the power amplifier, and it is the output. So I have actually in this box, which I will demo here today, I have put everything together. Both the preamp as well as the power amplifier, everything is in one box only. These are called integrated amplifiers. But you can buy them separately. When you buy them separately, the preamp can cost a lot. The power amp also can cost a lot, depending on the quality. So that is one aspect. Now this is the other important part. After the power amplifier, you have to connect your signal to the speakers. So speakers are hardly a single driver. As you can see here, in most cases you will have a woofer, which is for the low frequencies. Then you will have a mid-range for the middle frequencies. You will also have a tweeter for the high frequencies. So this speaker is a three-way speaker, because I have divided my frequencies into 3 routes. Now in many cases, I mean not always, but if you watch movies, then it is important that you also have a subwoofer which is sitting down here on the floor. That is for the very low frequencies, like in the range of, I have cut the frequency here for 110 Hertz. I designed the circuit for that. We got 120 or 130. It happens depending on the tolerance of your capacitors and all. So anything less than that, I would say typically anything less than 100 Hertz coming down to some 30 Hertz or something can be reproduced by the subwoofer. So this, do you really need to have a subwoofer? Yeah, I mean some people prefer to have it, some people don't prefer, depending on your system. So I would like to have it with very low volume. You know, it should not overpower the other channels, because it can be boomy if you don't do it properly. So subwoofer amp design is something you have to do carefully. Anyway, so this is what basically you have. And so nowadays we know that after the coming of digital, almost all sources have become digital. So you need to have the input part, that has to be something that can process the digital signals. So this is called in the jargon, this is called DSP remote kit. That is what they call this. So it will have all these inputs. So you can see behind the audio video receivers on some TVs also, you can see all the HDMI inputs and all that. So this is what they have, three HDMI ports, one coaxial port, one optical port. So you can see in many systems this coaxial and optical will be there. These are all digital pathways. So like, you know, if you take an Xbox or the PlayStation, so they will all have this. Even our satellite dish TV, so on that set-top box, on the back side, you will actually see HDMI and coaxial optical, depending on which model you have. So this is what sits in all these kind of devices by and large. So this is your digital input, and here you can get analog output 5.1. So this particular one is a remote kit for 5.1 decoding. So I will tell you what is 5.1 for those who don't know this when we talk about Dolby Digital in one of the following slides. Now that is the standard fare what I showed you, but now many people have started using a DAC as the source. No, people just say DAC. In all setups you need to have a DAC, but when you say DAC, what they mean is high resolution DAC. So this is a digital to analog converter. So what it does is, for example, let's say you have a FLAC file, you have a reliable FLAC file, you get it from the net and all that. There are in Telegram and all, I hear that. I'm not a member, but there are a lot of FLAC files, and people actually upload FLAC files, so you can download them. How to play it at that resolution? The normal CD players or whatever player you have will not have that resolution. So to get that resolution, you can either buy one, like for example, see, this is a DAC that you can buy, but this is all the low cost stuff. This is now there in Amazon. It has good reviews and all that. So you just connect your on the back side. I haven't shown the back side. So the back side of it can accept optical input and coaxial input. So it is only for that purpose. The other one which I am showing you here, it can accept the thumb drive, that's a USB drive. It can, I believe, also accept streaming files. So therefore, you can make it using the, it will be a good project for the engineering students and even school students to make using this Raspberry Pi and a hat. Hat is hardware at the top, right? So the same way, when you work with Arduino, you can buy some boards and you can keep them along with the Arduino. The Raspberry Pi is actually a small computer. You get it for some different versions are there. I think the good ones, the latest versions you can get for maybe 8,000 rupees or something. And then buy this hat, which is like 2,000 rupees. So within 10,000 rupees, you can in fact make a high resolution DAC, which works at, as you can see, 24-bit depth and 192 kilohertz sampling rate. So this is the highest. It is like the studio mastering, that kind of resolution. And then you also need a display because you need some software to drive this. So there are some softwares like Volumio, then Mood or something. Volumio is what I remember. So if you have a small box, a metal box, you can fix the whole thing there. Put this display, buy a display also and load Volumio in that, because Volumio will load into the Raspberry Pi. And then it can be a standalone unit and you get very good quality. The quality is so different. Only when you hear it, you will realize that what you normally hear from the normal USB stick and all that is much inferior in quality. Of course, you need to have FLAC files, otherwise no use. So this is possible. People are doing these things. So now this is the latest, I mean, at least in the general audiophile, I wouldn't call audiophile, but audio lovers communities, now everybody is focusing on the DAC because people now know how to make good amplifiers, how to make good speakers. So now people are concentrating on this part. Now comes the preamplifier. So the preamplifier basically is something that you will have several inputs to it. The phono input, that is the phonograph output. then you know, CD, DVD, tuner is radio, tape, aux, tape out and all that. Now this has become a bit outdated because nowadays many of these things, CD players, DVD players, CD players have kind of disappeared from the market. So many people don't have those things anyway, but this is basically the structure. And so you can have, so these are the kind of stuff you can buy from the market. There are several vendors, several companies are there, they are all there in Amazon, sometimes they sell on their own. So you can buy, as you can see, bass, treble, balance, volume, there are 4 controls. Even in this, you can see this box later, even there, that is what I have done. I bought all these things from the market. So, but this is a valve based preamplifier. You know, these valves or tubes are coming back now because of, they have some tonal qualities. So they are coming back and you get preamplifiers based on that also. So this is one of the older Marantz. Marantz is a very famous audio company, and one of, in olden days, like, you know, 30, 40 years or 50 years back, there were preamplifiers of this kind, real big boxes. This is a Macintosh preamplifier. They are still available actually. So you can see how many inputs are there on the back side. Different inputs you can connect. So that's basically what it is. Now from the preamplifier you come to the power amplifier. So I will briefly mention, this is what you call a class AB power amplifier, which is the normal standard these days. Class A, there are other classes, like class A is less efficient, but it does not have crossover distortion. So therefore class A is preferred by some people. If you are willing to spend a lot of money, because you will be spending most money on heat sink in a class A amplifier, because it dissipates so much heat that your entire enclosure will become a heat sink. People make enclosures based on heat sinks for class A because it will warm up a room for 5 degrees rise in temperature. It is capable of warming up, and you know, inefficient like 20% or so, that's what. But the tonal quality is very good. So just because of that, people do class A. Class AB is a compromise. Here your bias currents are lower. So and it performs reasonably well, actually pretty well. If you design it properly, it can perform very well. And so it has these 3 stages. The input stage, usually a differential amplifier like this, but sometimes it's a singleton input also. And voltage amplifier stage. So there will be one transistor which is used for voltage amplification here. And then finally you have an output stage. The output stage is where all the current is happening. Up to the output stage, it is all voltage. Okay, currents are very less, like 2 milliampere, 10 milliampere, that's all the current. But the moment you reach the output devices, they are big devices, as you can see here, fixed on big heat sinks and all that. So the currents they can handle are like, you know, 5 amperes, sometimes 10 amperes. You need that kind of heavy currents to flow through the speakers to get the real power on the speakers. So this is how a typical class AB amplifier will look. Now coming to the loudspeaker, this is the other important part of your hi-fi system. So you need to have a speaker. So I told you there can be 2-way or 3-way speakers, but some people prefer the full range. This is a full range speaker. So what it means is it tries to reproduce all the frequencies in your sound spectrum, but this is not a possible task. So the low frequency end will be attenuated, high frequency end also will be attenuated, but in reality I really don't know whether there is a real need to go beyond 15 kilohertz, for example. You may not hear that. Many people just don't hear it at all. So this is a reasonably good compromise. So you can see there is a big cone which reproduces the lower frequencies, and at the center there is a smaller cone. There are 2 cones here. That cone is called a visor cone. So the visor cone will produce the high frequencies. So it is a good compromise, the full range. Some people who make class A amplifiers, they will use only full rangers because they don't want to. The advantage of the full ranger is that you can avoid something called the crossover network. The crossover network, while it can be very good, has phase issues. So I will not really go into that. It will There are phase coherent crossovers also, but one needs to be a bit careful. The full ranger is free from all the phase issues. So therefore, some people prefer that. Anyway, usually you will have a two-way speaker for any decent reproduction. I mean, if you really keep the full ranger guys apart, a two-way is what is shown here. So you will have a crossover. You can see on the behind of my speakers, actually the crossover is sitting outside. So you can come around and look at it. I am not using the inductor actually, I am using only the capacitor, because I found this inductor here is not truly necessary. Even if it's not there, it is perfectly okay, at least in my system. So now this is a band pass, this is a low pass, this is a high pass. So different filters you have, this is the way you do it. And this is the filter characteristics, how they actually, you can see the phase shift. I was telling you about shifting in phase in the crossover region. So this is the structure of a three-way passive crossover. You have the original signal coming from the amplifier like this. So you can divide this complex signal into these various high, low, mid, then low pass, high pass, band pass, and they all go through all these different speakers. So that is what happens. So this is the frequency response of typical speaker drivers. So this is for the woofer, this is for the tweeter. You can see that it is crossed over at the right frequency. You really have to measure this. If you want to do a speaker all by yourself, if you buy from the market, they have done all this work for you. But always remember, you can make your speakers much better than those, because they are all compromised on the price factor. They are made by companies, and so you can make good speakers at maybe half or 1/3 of that cost if you compare quality to quality like that. All this can be done. There are calculations possible and simple calculations. And as I told you, the subwoofer, particularly important for the movies. When you watch movies, you know, the low frequency effects, in the movie this is called LFE, low frequency effects, like explosions, helicopters and all that, you know, very low tone. So subwoofer is a must for any Dolby Digital or DTS movie. It is a must. If you don't have it, you will miss, I would say, 40% of the sound of your movie in those encodings. So this is how it works. As you can see, it you know, from about 100 Hertz downward, it responds well. This is a two-way system. This is a three-way system. This is called a bass port. In some speakers, people use what you call bass reflex port. This is for improving the low frequency response. But at the same time, if you use a bass port, it will affect the damping factor of your speaker. So these are personal preferences. If at all you use a bass port, you have to properly calculate the positioning, the length. It should never be just behind. Some people by mistake give the bass port just behind the woofer. This is wrong practice. Should not be given at all. So it has to be at some other place. It can be calculated. Personally, my preference is no bass port. I would rather use a subwoofer for extending my frequency to the lower frequencies. So no bass ports for me, at least for me. Now this is a 2.1 stereo system. The 2.1 means you have the left channel, you have the right channel like this, and 0.1 is the subwoofer, so which is sitting down there. And this system is good enough for most TV watching, unless you are watching high definition movie which is encoded in Dolby Digital or DTS. So this demo system is like this. So I will use a laptop. This is my source for today. The left channel, the right channel. So there is an amplifier here, two amplifiers for each channel has one amplifier. So in today's demo system, in fact, I have used class D amplifiers. So class D is not really considered as good as class AB. But that is what I have today. So I should say that the performance of this system today is not really the best it can. I have class AB amplifiers, but I could not bring them. So this is what I have for today. You can hear them later, but my feeling is that class AB which I have, other circuits are better than this, and class A which I am in the process of making a class A now, I got the boards and all that, they're very simple circuits actually, will be even better. This is only for demo. So this is what you have here, and for the subwoofer part you have to add the left channel with the right channel and then put a low pass filter so that only the low frequencies are reproduced by the amplifier. So this is an adder plus low pass filter, and the low frequencies go to the subwoofer amplifier there and then gets amplified and goes to the sub. So, and I have cut the, I use passive crossover here for my speakers. Even though you see 3 drivers there, it is actually a two-way system because I have disconnected the mid-ranges from this because I did not like the sound of the mid-ranges. So I disconnected that, I changed the crossover and made it a two-way system. So this is what I have today. The power section, so what I showed you was the signal section. Now the power section is like this. So you have, your power is from naturally from 230 volt AC. There are some real audiophiles who actually drive part of their system from batteries, car batteries and all that, because battery does not have the AC ripple in that. So that is the extreme, there is a very famous amplifier, by the way, it is called Jean Hiraga, or Rang Hiraga, I don't know which is the right pronunciation French. So that one, in the original design, part of that amplifier uses a battery. So that's how it's originally designed, but people make the Jean Hiraga even now, but hardly people, some people still use car batteries. Anyway, I don't have a car battery here. So this is 230 volt AC. So I have 3 different power sections for this. I am not saying this is ideal. I should not have done this. My preference would be to actually have just one power source, just one transformer with different tappings at the output, or completely separate 2 channels. There are many ways of doing this, but I had to make this based on whatever I had in my hands. So that's why it came like this. So I have one SMPS, so that gives me 0.24 volt DC. The advantage of the SMPS or switch mode power supply is that that can give you high current in a very small, you don't need a transformer, you need only a board. So the SMPS board that I have here in my system today is costing me only 900 rupees. A transformer that gives you 5 ampere at 24 volts can easily cost you around 1800 rupees or something. Now add to that your filter capacitors, all that, you can easily go to 2500 rupees. But my SMPS I get for like 900 rupees. But the cost, I mean, nothing is, you cannot just economize like that everywhere, right? The problem with the SMPS is it's noisy because the way it works, it uses switching transistors. So the output power has some noise in that. So you have to live with that. But I get that in a small footprint without a big transformer and all that. So I use a class D amplifier, as I told you there. That is also a small footprint, doesn't take much space here. However, most of the power I am spending here for the subwoofer actually, and you can hardly hear it. That is the fun part of it. I have a transformer 25025 volt AC, 5 ampere. So this I got wound from SP Road. There is a shop, Universal Transformers. If you go and wind a transformer, just go there and tell them you are from the Planetarium or you attend talks here. They know, then they know you are looking for quality. So it's a business, so they make normal transformers. For me, I contact them through our technicians in RRI, then they make really good transformers with good copper winding and all that. So it is costly, but so I spent GST I think 2300 rupees or something, which is slightly on the higher side, but I have a really good transformer, you can see that sitting. So I use that, and then there is a subwoofer amplifier there, one board. So I also use something called a soft start because the reason why I use this is because there are capacitors in the circuit which are of high value. So you know, capacitors are like storage tanks. So initially when you switch on, at that moment they are empty, there is nothing in. So they will just draw the current from your source. From the transformer it will just draw just like that. So this is not always very good, and if nothing else, it can actually cause a thump in your speakers, the boom sound for example. It may not be damaging, but there are also other ways of protecting that, I mean stopping that. Anyway, so I used a soft start circuit. So the soft start will slowly start, I mean it does not start in an instant. So initially the current will flow through a resistor. After 2 or 3 seconds, it will switch over to a relay. So the initial surge is arrested. So that is why I have a soft start circuit here, then the subwoofer amplifier here, plus the amps here. Then I also have another transformer. So this is where I made, I mean this is suboptimal, because if I had the right transformer, I could have taken power for all this from the same transformer with different secondary windings. So I did not have that. So I have to put another transformer here with 2 amps, 12-0-12, and this powers the tone control board, which is the bass, treble, all that, and also the speaker protection. So now what is speaker protection? Now in any amplifier of this kind, unless you are using very cheap speakers which you are willing to kill, okay, because when you do these experiments, we will kill some of our parts actually. I mean, even yesterday it happened. So by mistake we connected the negative and ground power to our, because these are dual power supplies, plus, minus and ground. So by mistake to the tone control which I am using today, these things got reversed, negative and ground, because you know the wire color, it's just the color, and so it ran like that for 15 minutes, and even the subwoofer amp was not working properly, and there was high dissipation, the ICs, regulator ICs were getting heated up. So we realized there is some issue. I have 2 technicians helping me, I will thank them at the end of this talk. So we realized something is going wrong, and then it takes some time to really identify the problem. We did not quite identify the problem even up to the evening. Then suddenly one of them realized that okay, these 2 wires are reversed. So then we took out the board, we connected power properly to it, and we checked in using the oscilloscope and frequency generator and all that. So there is some small issue, but it is still on the bass side, and on the balance side there are issues. So I will replace this board. So I have spoken to the vendor who gave me, so this is a vendor from Trivandrum. His company name is D-Tech. So actually he sells a lot of these boards. Half of the boards you see in my system here, I bought from D-Tech. You can contact him. His name is Prince. He can be contacted over WhatsApp. He also supports you. Like once you buy something, if you tell him there is a problem like this, he will tell you what are the possible issues, and he will helps that way. So there are also other, D-Tech is one reliable vendor, and there are other people also. So that's how. So okay, I was talking to you about speaker protection. Now why you need speaker protection is that the speakers are not supposed to handle DC voltages. So they need only AC voltage, the signal voltage. If DC goes into that, the speaker has a winding inside, the coil will die if DC goes into that. So imagine expensive speakers dying like that. You can get them repaired, but whatever speaker I got repaired never came back to the original performance. It will play, that's some problem will be there. So don't kill your expensive speakers. Like one woofer from Peerless or Mark Audio can be like at least 1,500 rupees. These are all the lower stuff. So it can be more expensive. So we put speaker protection. Speaker protection I can show you here. So these are relays. So these relays will activate if at all DC voltage comes to the speaker by a malfunction of your amplifier. Your amplifier can malfunction after long usage and all that. If it happens, speaker will be protected. So these are the basic things here. So you can see this, you can see the subwoofer amplifier here, the SMPS here, transformer here, soft start circuit is here, the space, okay, when I took the photo, tone control board was not fixed. So it is here, there, and class D stereo amplifiers, speaker protection. So this is how I have aligned in my system. Okay, you can also have something called active crossovers. The active Dolby Labs introduced Dolby Surround. So this was just 2 extra channels which were generated from the existing stereo channels. So everything was stereo, so 2 channels. So just add and subtract. So by that way you can generate the surround channels. But then in 1983, Dolby Digital 5.1 came. So this is a benchmark for all the movie experience. So you have the right channel, the left channel. The 0.1 channel is the LFE, that is the low frequency effects, then 2 surround channels. This is usually sufficient for normal kind of home theater. This will satisfy most movie requirements. So you can see the first Dolby Digital movie was Batman Returns in 1992. Then DTS came, originally it was called Digital Theatre Systems. That is another format for movie, very similar to 5.1, but there are some differences, like the bit rate is higher compared to AC3. And the first DTS movie was Jurassic Park in 1993. Now we have Dolby Atmos. So Dolby Atmos, it adds channels above your head. So therefore, you know, for some scenes Dolby Atmos is good, like when it rains and all, you can actually feel the rain coming from above you. So Atmos is a standard nowadays. Most audio video receivers, AVRs, if you go to buy from the shops, you will get Atmos in that. Then there was something called, there were several other formats which did not really pick up, like Sony Dynamic Digital Sound, SDDS, was there for a while, but it quite did not pick up. So DTS and Dolby Digital, Dolby Atmos, these are the typical standards now. And this is the RRI auditorium, where we have a 7.1 Bose system. Bose is a well-known manufacturer. And now if you want to make a home theater, so why people get a little deterred from making a home theater, because it's the cost. However, nowadays there are very economical projectors available. For like 8,000 rupees, you can buy a projector, and you can just, I'll show you a photo of the projector at our home. I made a home theater with all these components very cheap. So 8,000 rupees, if you spend 10,000, you get, and these are enough for home. If it runs, even if it runs only for a year, I really don't know about the durability of these, but many people are buying these, if they are using it. You can look for reviews in Amazon, for example, and look for something which has good review. They work. So you have you have the normal satellite dish from which you get high definition movies, 4K movies, for example. So then take the HDMI output, give it to the projector, and take the 2.1 audio out, or 5.1, sorry, it should have been 5.1, I wrote by mistake 2.1. So take it out and use all this, and you just need a screen. I don't even have a screen, I am just using the wall as my screen. White, it's not even painted in white, it's off-white. That is okay. In the night, only problem with this kind of projectors is that the brightness of these projectors is much lower than that of a TV. The LED, OLED, QLED, there are many types. So it doesn't come anywhere near the brightness of even that of a normal LED TV. So therefore, if you want to watch movies during daytime, just make sure that you have good curtains. Maybe curtains with close to black color, something like that. You have to draw the curtains, otherwise you won't be able to watch. But in the night, this is perfectly okay. So you can just have your movie theater in the night at home. Let's say after 7 o'clock or 7:30, if you just switch off the light in your room, it's perfect. Have some light behind you or something. I mean, I can perfectly enjoy a movie like that. And the screen is pretty large. It depends only on the distance from which you are. Some optimal distance is there in your living room or in a bedroom. If you have a reasonably spaced wall there, you can have your own home theater. It's not really going to cost much. Okay, so this is the, at our house, this is the projector. I have fixed it using some rod which I could buy from Amazon, I think, again. And so this reminds us of the RRI projectors. Same technique, basically, yeah. So, and this is the streaming device. That is an Xbox. And then, you know, this is just an AVR, audio video recorder, which I use for decoding the Dolby Digital data that comes from the satellite. So that's what basically it is. And well, I'm close to finishing this talk. Now the recent trends in audio are like, you know, forgotten technologies like valve or tubes. In the US they say tube, the British and we say valve. These are now coming back, like, you know, the turntable, which had completely disappeared, is now coming back actually with analog recordings. So you get the records, the discs. They are pretty expensive. Like when I checked, I was planning to have one, but what deterred me is the cost of the records. The vinyl record itself is costing like more than 2,000 rupees. If you want just one vinyl record, it's costing like that. So that's why otherwise I would have really looked at this older technology once again. But then anyway, it is coming back. And maybe in India the prices will, because in India hardly these things are, only very few people are really using these things at the moment, but it will pick up. It will take some time. So by then the vinyl records maybe will be cheaper. And I had a very good experience in the US. I was in Seattle at that time, and with my brother-in-law, and we went to this shop called Magnolia. So Magnolia, I don't know where it exists now. It was bought by Best Buy. So in Magnolia, actually, we happened to see the very special area. I mean, for the normal customer, they don't even show, they don't even tell them that this area exists for audio devices. So when we went in there, just by a stroke of luck, we happened to talk to a pretty senior salesman. Turned out that he is not only a salesman, he is also an audio engineer. So we asked him some technical questions. So then he told us, I'm happy to see customers like you because you are asking some technical questions. I will show you something which is on the back side of the store. Just come. So we walked with him. So we went inside, and it was a small door, like, you know, I mean, it will look like a toilet door or something. You will never believe, you never even think that this kind of stuff is sitting behind this small door. He opened the door and called us inside, and it was a completely different ambience. You know, in the front you have the normal, all the usual stuff there. As you move in, even the lighting is different, even the mood is different there. So lot of tube amplifiers glowing like this. Okay, it has a glow because the valves glow. Then very expensive speakers. You know, there are preamplifiers, amplifiers, very expensive speakers. I'll show you one of those which we saw there. That immediately we told him, we are not in a position to buy, because we could see the price tags. We can't buy these. So he said, no, it's okay. I perfectly know you guys cannot buy any of these things, but I would just like to show you what is possible in audio. You don't have to buy it, just hear it. It was a beautiful experience. So we were there for half an hour. When you come out, what you think is that, my goodness, what crap do I have at home? Now this is music. Huh? But then you can't afford this. They are so expensive, made for specific, the high-end customer. So these things are now coming back, and this is a tube amplifier, a valve amplifier circuit. I mean, you can see the circuit itself is hand drawn or something from 50 or 70 years back, and there are many differences, like even the output is not directly coupled. This is transformer coupling and all that. So even making these transformers, there are some people in India who the output transformer making is not like a normal transformer. So I found out that one contact in Madurai, his name is Mr. Narayan. So Mr. Narayan is actually making these output transformers. So I told my wife that we should actually make a pilgrimage to Madurai sometime to really, I will go and meet this person. So so I will do that. Similarly, I went to another place in Kerala some 2 months back to meet an elderly person who was making valve amplifiers. But unfortunately, we heard the news that he passed away in April 2023. He was pretty old. So he was making them, and another agency was helping him to export. So no sales here. It was all being exported. So like that. So these things are now coming back. Now the question is why? Why do people want turntables and tube amplifiers now? Because you have all the digital, everything is here. So why do you want to go back to the older technology? The reason, there are a couple of reasons. First of all, the analog record discs are the olden time. They are lossless. There is no loss because the studios were analog in those days. No sampling, no bit rate or anything, okay. So this was perfectly analog, but the issue is it has its own problems, like noise level will be high, for example. But this is no compression, no loss, nothing. So that is one thing. However, it is to be remembered that even though these people make these record discs now, they are all made in digital studios. So the master for that, people say, is actually digital. But digital with very high resolution, like 24 bit 196 kilohertz. So therefore it is very high resolution. You cannot differentiate analog from that. So that is fine. Then you make the disc, analog disc based on that. So that is one thing. Secondly, all tube amplifiers are mostly class A. I mean, they are not designed, only a few are designed for class AB. So class A and single ended. So there is no crossover distortion, unlike in the case of class AB amplifiers, which are what we have mostly. And it is not to say there is no crossover distortion, but there is something called even harmonic distortion. This is second harmonic, fourth harmonic, like that. This harmonic distortion is what gives body to the voice. So when somebody sings, why is it that for some people the voice is so sweet and for some others it is not so sweet, even though they can sing exactly at the same pitch, exactly at the same notes? It's a question, no? The reason is harmonics. So why the voice of Yeshudas is different from Chennai Vaidyanatha Bhagavathar, even though both can play, both can sing the notes exactly the same way. This is because if you analyze the tonal, the voice of Yeshudas, or any singer, any good singer for that matter, you will see that in addition to the fundamental note, there are many harmonics. So it is the combination of the fundamental note plus these harmonics which gives timbre to the sound. So this is called timbre. So timbre, this is what timbre is. So it's a timbre that makes somebody's voice sweeter, somebody's voice harsh, and all that among musicians themselves. Now, Carnatic music, for example, a Carnatic player is singer is usually never gauged based on the tonal quality. It is the singer is rated only according to the perfection of the notes. That is why you don't need to be a movie singer to be a great Carnatic musician, for that matter. Carnatic musicians don't bother at all. That is my small experience. They just don't care about the sweetness of your voice or anything. They look only at the the perfection with which you sing. Anyway, this is true for any classical music for that matter, because it's just a scientific discipline. So, the even harmonic distortion gives something called warmth to your voice. So that is why a valve radio, for example, the moment you switch it on, the sound that comes out is quite different from what you get from a transistor radio. It's because of the large second harmonic and then the even harmonic distortion. So these are the reasons. Then there are also other things like the negative feedback is minimal in valve systems. So people say that that also helps in reducing the distortion. So this is an area of ongoing debate among audiophiles. The audiophile is the person who actually will spend any money for getting the best audio experience. There are people who spend thousands of dollars just for an interconnecting cable between the amplifier and the speaker. There are companies which sell cables like that, $1,000 for 1 meter. Now you will wonder, are there people to buy this? Yes, there are people who buy it. Whether they hear a difference, they will hear a difference. Actually, I mean, there is a science behind this. These cables have larger values of capacitance and inductance. They make it like that. The companies make it like that on purpose. If you use a cable like that, you will hear a difference. And it is the duty of the company to convince you that the difference you hear is a better sound. And if you have a lot of money in your pocket, you can certainly buy it. So that is what is happening in, this is called snake oil in audio, snake oil in audio. Anyway, I am using 10 rupees per meter cable and I am pretty okay with it. So this is why turntables and, okay, so music revenues are now coming from records more than CDs. Last year, the record sales actually went above the CD sales. So some hi-fi speaker manufacturers, this was actually one of the speakers I heard in Magnolia in 2012, and in Indian rupees it is costing 55 lakhs including import duty. So there it will cost half of it, about 27 lakhs. There are even more expensive speakers. These were excellent actually. So you know, Bose we know, I mean Bose is Indian basically. So Bose is good speaker. Now many references are used for this talk, like DIYaudio.com. If anybody wants to do on audio stuff, just go to DIYaudio.com. It's a very good site with lot of information. Similarly, sound.au.com. Lot of circuits are given by somebody called Rod Elliott. So I have to thank many people for this. First of all, Sujata and Meena for excellent hardware support. They have been supporting me a lot, our technical officers, with all this. And our RRI Carpenter also has helped me come in. Then Rod Elliott, I have met him personally. He is actually one of the legends, I should say, in Class AB. So met him at his house in Sydney and we had a discussion for about an hour. Very stimulating discussion. Dr. Joni Isaac is my guru in audio. So he taught me the initial things, and these speakers we made together 30 years back actually. It's mostly Joni's effort. That's where I started learning. Then students and RRI faculty colleagues who share interest in audio, and Vidwan B.S. Anand Malleshwaram for our family's music teacher, and my family for suffering me with all these, you know, the audio journey. Yeah, so thank you so much. Thanks a lot. I think I took some little more time, but. Thank you.
So now the floor is open for questions. The mic will come to you. Please speak into the mic.
You can raise your hand and I'll get you the mic.
You mentioned about the surround sound,
Yeah.
but how is that effect actually created? Can you explain that, like
Yeah. This is recorded in the studio like that. So, like for example, see, you have surround speakers. So imagine you have a helicopter moving on the screen. So it is going from the left to the right. So when it is on the left edge, you will actually see the sound coming from the front left speaker. As it goes to the middle, you see it happens to the center speaker, then it goes to the right, and once it goes out of the scene, you start hearing it through your back speakers. So in the studio, it is recorded like that. Yes, because it is 6-channel. The audio, that's why you have to use the HDMI. See, either HDMI cable or you have to use the coaxial or optical. In that, all the 6 channels are encoded in PCM, pulse code modulation format. So this is decoded, encoding and then decoding, and it goes to separate channels like that. Yeah. Yeah.
On this old records, how exactly is it the sound stored? I mean, is it like just the...
There are groups there. So what happens is these groups of in the original recording, in the groups you will have, those corrugations and all that. So when you put the cartridge there, the stylus, when the stylus moves through that, it moves. So when the stylus moves, it can generate the voltage in the coil which is attached to it by electromagnetic induction. That is the magnetic stylus. For the other stylus, which is piezoelectric, it is just piezoelectric effect. So the stylus moves and then you have a piezoelectric voltage. That is the way it works. Yeah.
When there was no electricity, how was recording done?
Recording was mechanically. See, that's why that the big horn is there. I showed one of in one of the earlier. I can show. Yeah, here. See, here you can see a big horn. So everybody was singing into that. So at the other end there is a needle. There is a diaphragm and a needle. So a diaphragm will vibrate. Then the needle will actually make the engraving on wax, because this was wax cylinder that time. And then you roughen the wax or something. There is some process. And then when you play it back, like the same wax cylinder. So the problem was, in those days, for one recording only one wax cylinder could be made. So therefore the musicians in those days, I have read about one musician who did a performance 25 times a day, same thing, to make 25 such cylinders. And now this is what happened in those days. So this is a cylinder is here, actually cylinder is sitting there, and that needle, the reproducing needle, is moving on that. There are videos of this in the internet. One can check and you will find it. It is wound, again it is wound, like the winding handle you can see. It is wound, then you allow it to run, and then the needle goes over that and through the megaphone, because the megaphone amplifies the sound. So through the megaphone you can hear it. There is no electricity. It's all mechanical. Yes, engineer.
Reji, I remember you making your own car audio about 15 years ago. So, how would that differ from this?
Okay.
And are you going to play this for us?
Yes, okay. I will do that. So, car audio, car audio is much more challenging actually, because the environment you have to, if you want to really do it properly, this is very challenging, because first of all you have to look at the structure of your car, and you have to reproduce your bass frequencies and everything properly. So you need the right speakers for it, and electronically it's the same. The electronic part is same amplifiers. Only thing is, the only difference is whatever amplifier you use there, you have to drive it from 12 volts, 12 volt DC, car battery. Now these are driven at a much higher voltage. For example, I'll be using something like 50050 for my subwoofer amplifier. So 100 volts in total will come there, but for the car it's 12 volts. Some amps are driven directly from the 12 volts. In some cases, they actually convert it to 230 volt AC or some other high voltage, then drive from that. It's a big field, so that's the way it is done. The most critical is the speaker placement in the car audio.
So there are some questions
There is
online.
Sir, in this one, there will be only monotone, means not stereo.
I think these are all mono.
Okay.
Yeah. Stereo came much later in the disc. I haven't read anything about stereo in the wax recordings.
And how we record the stereo, means we place the recorders at two different locations, or?
No. Actually, see, in the studio, when recording is done, there are different microphones. So these different, in some cases, I will actually play one song where this is panning from one speaker to the other. So this is done in the studio like that. The engineers actually record, there will be in stereo minimum 2 channels. So these mics are properly mixed into each channel separately like that. That is how you get the separation.
So they will keep 2 mics for recording at some.
Not too much more. Each instrument needs a mic. So much more. Many more will be there. 10, 15 mics will be there. And the singer is always in an anechoic chamber. You have must have seen that in videos, right? So the singer, first of all, there are no live recordings anymore. It is all gone. That era is gone. We are talking about the case when there were live recordings. The orchestra will be at one place. The singers are always in chambers, but they will hear the whole thing through earphones. So they always keep the headphones, they hear it, they sing with that. But now this is all track recording, and the song is sent to the singer. Usually the singer sings at his or her own home. They will have a small studio there. So that is what happens, unless real commercial productions where like people like Ilayaraja, A.R. Rahman. So I think it was for Ilayaraja, it was a music factory. So I mean, so many songs were being made. So singers would come to the studio. So everything will be pre-recorded. So then the singer sings along with that. So there is a lot of job, lot of work for the sound engineer, mixing, everything.
Sir, one more. You said that means bit rate. Bit rate is multiplication of 3 things: sampling frequency and depth.
Yes,
and then
correct.
The number of channels. So you recommended that at least have 256 kilobytes per second.
I would say CD quality, that is 1100, close to 1100 kbps. So that's the audio CD quality. That is good enough to hear if well recorded. Now what we normally hear is MP3. That is so ubiquitous that you hear MP3. In MP3, 320 kbps. With 320 kbps, with a decent sound system, you can play it well. But if you have a very good sound system, highly revealing sound system, then you will hear better from the higher resolution, from a FLAC, for example. In fact, FLAC will play better even in normal sound systems compared to MP3. That is the experience. So my next project is to make a DAC. I still don't have a DAC. I just play these things. So I am planning to make a DAC now using Raspberry Pi and one of the hats. There are a few 2-3 hats available. So within 10,000 rupees, it is possible to make the DAC, and then I will use that as my source now and drive FLAC files through that. FLAC files are available. And I can use a spectrogram, use the spectrogram for really finding out whether these are FLAC or not.
Thank you, sir.
Yeah.
There won't be any.
No, there are channels. Audio always comes in 2 channels. Stereo. It comes in stereo only. So 2 channels will be there.
Okay.
Yeah.
So Dolby will be always useful.
Sorry?
Dolby like 2.1 will always be useful.
2.1, see, usually the 0.1 we have to generate.
Okay.
It is basically there in both channels. The low frequency information is there. The 0.1 we generate using our equipment. Yeah, from that. We don't really generate anything. We just separate out the low frequency part and then reproduce that through yeah. I'll play that alone so that you can hear what is that low frequency part. Yeah. So audio comes always in stereo. Dolby comes in 5.1. Dolby digital and DTS comes in 5.1. Atmos comes in 7.1 because 2 more channels.
So okay, that implies that any 7.1, if you have a sound system, if the audio is 2.1 channels stereo, then they won't have much value for such audio systems in a way.
No, 7.1 is audio. In 7 so this is what happens. Let's say there is a movie.
Okay.
The movie video will be normally in 4K. I mean, nowadays most things are coming in 4K. The audio part alone, when we say 5.1, 7.1, it is only the audio part.
Right.
We are not talking about the video part at all.
Right.
The video we usually say HD, true HD, I mean, companies give so many names to it. Then 4K is, I think, now the standard. 4K is very good video. Audio part is 5.1 or 7.1.
Yeah. My question is like if audio is recorded only 2 channels, then the 5.1 system won't have any value.
No. These are different.
What is it?
These are different. When I told you audio is recorded in stereo, I was thinking about CD recordings or normal songs which you hear but you don't see. You only hear them. So when people do that in the studio, it is always stereo.
Okay.
It is only meant for hearing. Not whenever there is a movie. In the movie you have to accommodate all the effects, no? So therefore, then they will record in 5.1 or 7.1. Yes. So these will come with movies normally. Yeah. Oh, no. No, you can have class AB, class A, everything with MOSFET. Class D basically means switching. So switching transistors are used there. The signal is switched at a very high frequency. It's like 500 kilohertz. So that's the kind of frequencies nowadays people use for switching. So the idea there is that for that you can use any switching transistor which will switch at that high frequency. That's all. MOSFETs maybe people are using. So this one in my class D amplifiers, I think the IC is 7394 or something. I have forgotten the actual name. It is there in Amazon. I can give you the details. Yeah. So not necessarily, I don't know whether they are all MOSFETs. I don't know about it. But MOSFETs you can use in class A and class AB installations also. People have done that. IRF 9240, that kind of MOSFETs. Then actually 2 weeks back I bought a pair of MOSFETs from SP Road at a very high cost. A pair costed me 1800 rupees or 1700 rupees. They told me it is a matched pair. You don't even know whether these are originals because it's very hard to get Toshiba original ICs now, transistors and MOSFETs now. So this is a reliable shop and hopefully it's a good pair. I mean, it's a real original. I don't know. Nowadays it's very difficult to get original ICs and all that. So what I do in many cases is that I use normal 2N3055, that kind of transistors. These are actually good quality. CDIL is a company, Bangalore based company. They are making good quality 2N3055. Only thing is we have to design our amplifiers using this, which can be done. And very good quality we get. So no need to worry about, it costs only 40 rupees for one. No need to worry about fakes or anything. CDIL is Bangalore. Bell used to make it, Bell is not making anymore.
Okay. Yeah, okay, so there are several questions actually.
Oh, online 7 questions,
So I think you've already touched upon it, but the question is, Rakesh is asking, is there any real difference between class A, B and D amplifiers in terms of output quality of sound?
Of course, yes. The answer is yes. There is a real difference which you can perceive with your ears.
Okay.
Yes.
So tube amplifiers, is there a boom for it in the future?
Yes.
There's a question
Yes.
by Sri Kumar. You get dedicated USB DACs, DACs with mobile phones.
Yes.
Any experience with those?
I haven't used them. I know they exist, but people who have used them, see, it all depends on the resolution with which they say it's a DAC. We have to look at the resolution of the DAC. So that's why, you know, some of the, I mean, in Amazon, I showed one of the slides where it is costing like 3,000 rupees or something, but that will be limited in the resolution. What I would suggest is, rather than, of course, people can buy USB DACs, many people are using it, and many people are saying that they are good to hear, they are better than the normal this thing. But personally, I would prefer to make a DAC based on Raspberry Pi, which is one of my future projects, because many people have said very good opinion about it.
Okay. So Shri is asking, where do we get the modern LP players and LPs in Bangalore now?
That's a difficult question. See, I really don't know. There are some LP players in Amazon. These are all Chinese make. Like, you know, for even 5,000 rupees you get them. But then I really don't know about the quality of, because the cartridge itself, the starting price will be something like 3,000 rupees for a normal cartridge. So if we are really looking at high quality, a 5,000 rupees LP player is a record player is not really going to be the ideal thing. Maybe a possibility is to look for vintage sellers. There are people who sell vintage stuff in working condition. These can cost a lot, but these are the things which I would really advise, because I don't really know about any manufacturer in India who makes these things now. So better go for vintage.
Thank you. So I have one question.
Sure.
So I mean, you have not touched upon this, you know, earphones. So for example, you know, you have a 7.1, 5.1.
Yeah.
Those cannot be replicated on a earphone.
Not really.
Not really.
Well, I mean, there are some, actually there are some softwares which you can use for doing this. Like there are simulators for this. I don't know how good they are. Maybe they are good. So it's all, because these are all different phase relationships between different speakers. So if this can be generated, because it's the advantage of digital audio, by the way, you can do all manipulation. So probably these software, these programs can actually do that. I am not really much of a fan of headphones, so I haven't really used them. I have never really used any headphone that is more than 1,000 rupees. I prefer these bigger systems actually. So I may not be the right guy to answer this question properly. Yeah.
Thank you.
Acoustic guitar, how the shape of the box of the
acoustic guitar. Oh, this is actually an art, making them correctly. So what I have read is that the wood matters. The wood matters a lot in the tonal quality of that. Then beyond that, I really don't know, because you have to probably in olden days, violin, for example, similar situation. Which violins are sounding better? So the real good violins, the starting price for my son, for example, when he started learning violin, the teacher said, now you can start with a Chinese violin that cost you 3,000 rupees in the market. So we bought this 3,000 rupees violin from some shop. Now when you passed which grade? Third. So fifth. So after fifth grade or something, the teacher said, no more 3,000 rupees violin. Now go for better violins. And they will start costing like 20,000, I mean second hand or third hand, 20k, 30k. So eventually I found somebody from Trivandrum and who managed to get me a good violin from somebody's old stock. So I paid 20K for that, I think. So now he is using this 20,000 violin. Now if you want to go to the next level, it can cost like anything. I mean, I can see some people in YouTube, they're playing so well. I mean, these are Western violinists, they are doing so well. But if you look at their violins, you see that they are not the kind of violins you normally see in the performances. These are special. So same way, you know, I mean, this is all high-end audio area, and I think the prices can be very high for, of course there is theory for it, but I don't know that theory myself. There is theory for everything in sound. So yeah, that's it. But wood matters, that I know.
Okay, thank you so much. Now
Thank you so much.
you can probably continue with your questions outside
So there is
while
a
having
demo.
coffee. Yeah, there's a demo right now. Yeah.
Maybe
Yeah.
we can have coffee and
have
the demo at the
Yes,
same time.
Yes.
Okay, no?
Thank
Get
you
the
so
coffee
much.
here and play it for 10-15 minutes, and then we can disperse. Thanks a lot for